Good morning, everybody. Thank you for joining the Turfgrass Epistemology YouTube and podcast. I'm Travis Shaddix, past professor, assistant professor, not a professor, assistant professor at University of Florida, University of Kentucky, and past salesman, past all this stuff. Thank you for joining me. Before we get going on today's article, a few housekeeping items. One, I broke off a piece of my tooth, so I got to go to the dentist. I was on a call list, and they called me for Thursday morning, right during the normal time I would broadcast. So instead of dealing with a broken tooth, I'm going to go fix my tooth on Thursday morning. So I'm going to try to either do the Thursday broadcast later in the day if I can speak. I don't know if I'm going to be unavailable to speak at that time or not. I don't know. If not, then I'll try to do it Friday. So I don't ever do really Friday morning shows, but I'll try to do it on Friday morning if I can't do it on Thursday, because if I'm all shot up with drugs, maybe I can't speak on Thursday afternoon after I get back from the dentist. So Thursday morning a no-go, maybe Thursday afternoon. If not, then Friday morning I'll do the Thursday show on Friday morning. I've been trying to schedule Wednesday show in the evening to try to catch some evening people who can't make it during the day. We're not going to do that this Wednesday, but for a very good reason. Tomorrow morning, it's early, so tomorrow morning we're going to do the show at 8 a.m. Eastern Standard Time live. The reason why we're doing it early is because I have a guest, Dr. Ross Brown from Kansas State, is going to come on and be with me to go through his paper about low input turf grasses and the pesticide and fertilizer requirements of low input turf grasses. He recently published the paper, I think it was last month. So the time that he was available was 8 a.m. in the morning on tomorrow morning. So please make a note of that if you want to participate live or ask Dr. Brown any questions. You'll need to be on at 8 a.m. Eastern Standard Time. So for those folks in California, I know there's one or two people in California who like this time. Well, it's 2 hours earlier tomorrow. But for Randy, if I recall, you're on the other side of the planet, so it might be better for you. I don't know. So anyway, tomorrow 8 a.m. Thursday morning is not available. I'll do it Thursday afternoon. If I can't do it Thursday afternoon, I'll do it Friday morning. And then next week is the fall break here for public schools in Kentucky, and my children are out of school, so I will be also unavailable for that week. The following week, so now we're talking 2 weeks from now, we're going to switch gears and start talking about warm season grasses. So fall fertility for warm season grasses, either things like nitrogen applied in the fall, or potassium applied in the fall, which I think we already covered one, potassium in the fall, or things like seaweed extract applied in the fall, ratios of N decay applied in the fall, all those things for warm season grasses. So there's a lot more to do with cool season grasses, but I don't want to go too far into the fall, being October now. By the time I talk about that, it'll be the second week of October. Before I start talking about warm season grasses as well, because parts of like Mississippi, Alabama, Florida, it's not they're already getting their fall programs together for the warm season grasses that they manage. So I want to get some information out there for the warm season folks before we go too far down the road. So that's the plan for the next couple of weeks. All of it is subject to change. Okay, let's get started on today's paper. Today we're talking about one of the first papers I'm aware of. I'm sure as soon as I say this, someone will pull up a paper from 10 years earlier. As far as I know, this is the first paper that talks about phosphorus during turfgrass establishment. It's entitled Effect of Nitrogen and Phosphorus Placements and Rates on Turfgrass Establishment by King and Skogley in 1969. So there may be others. I'm sure there are others, but I haven't been able to find them anything earlier than this. So we're going to discuss this to kind of provide a little bit of a foundation as to the work that occurred after this. There's a little bit of information in here that shows there's some value, but the results are quite inconsistent when it comes to the phosphorus responses. So let's get into it. Right from the abstract alone, again, this was let me see where this is published. This was published in They don't. Where's the Agronomy Journal? So it was published in Agronomy Journal in January-February edition of 1969. Okay, so this is one of our top tier journals, Agronomy Journal. There's 4 or 5 journals in the ASA, and this is one of those journals. So it's a high impact factor for our industry, a high impact factor journal. The abstract, the last couple sentences, says this: response to phosphorus levels was inconsistent. No significant differences in root weights were detected. So if you're looking for a quick, what happened sort of thing, this is going to show you right now. We're going to read through this in more detail, but the responses to phosphorus, there were some times when it did have a positive impact. There were some cases when it did not have a positive impact on turfgrass establishment. So let's read through it. It's a really short paper. I think it's only 3 pages. I may end up reading more than I normally do. But the introduction is literally 2 paragraphs. So back in the 60s and 70s, some of the papers, in my opinion, were actually much more useful. I don't mean to knock papers today, but they were more useful because they were straight to the point. You didn't have to meander through 3 pages of an introduction to get it published. Okay, it was straight to the point. This is why we're doing it. This is what we did. This is what we found. This is what's important, and that's it. Nowadays, you got to kind of do a lot. There's a lot more robust standards, I guess, or more. They want more information, and sometimes I think we distract from the purpose of the paper when we put so much information into a single paper. This is not one of them. They're very simple. Various recommendations on rates, ratios, and placement of fertilizer for turfgrass establishment have been made, and he has 4 citations for various recommendations. In particular, the recommendations vary in the amount of phosphorus recommended relative to nitrogen and potassium. So the amount of nitrogen suggested varies. Fertilizer placement recommendations include raking the fertilizer slightly into the surface, incorporating it into the top couple of inches, or tilling a little bit into the soil and leaving a little bit on the surface. The purpose of the study was to determine the efficiency of 3 fertilizer placements, 4 phosphorus rates, and 2 nitrogen rates as measured by initial and long-term turfgrass response. So basically what he's saying is these have been recommendations, these citations he has here, that he's just simply saying people have recommended certain rates, people have recommended certain placements, but there isn't, as far as I can tell from this study, when he wrote this, there wasn't at that point any sound, solid numbers to confirm one way or the other what should be done. So what did he do? The materials and methods, what did they do? The first field trial was established in 1963 in September. The second was seeded in June of 64. Both trials had the same treatment combinations. The trials were located I can't read that, Bridgehampton, and that's the soil, Bridgehampton silt loam, at the Rhode Island Agricultural Experiment Center. So we're in Rhode Island. Soil tests indicated that less than 250 grams of phosphorus per 100 square meters and less than 1 kilogram of potassium per square meter were available. These levels were considered to be low. Now, when you do the math on this, 250 grams per 100 square meters is an odd soil soil concentration or soil number. You don't really run into that. These are the older ways they used to do things back then. But this value, one, is not going to be very relative to us today, and I'll explain why in a minute. But 250 grams per 100 square meters is roughly a half a pound of phosphorus per 1,000 square feet, which, let me do the math. So if it's roughly, so let's just do it exactly. 250 divided by 490. So, okay, so it's 50%. So 50, hang on. It's roughly a half a pound. That's just like I said, so 0.5. So half a pound, and you take half a pound times 43, which would be 22 pounds of phosphorus per acre. 22 pounds of phosphorus per acre. So Lush comments in the chat, you can see Rhode Island from your house. Okay, so that's that's where you're up. Good. So this is kind of relevant to your area. So 22 pounds of phosphorus per acre was the soil test phosphorus level. However, the soil test extractants, hang on a second. The soil test extractant in 1969, let me see if I can get to it. I thought I had that in here. Let me get down here because I think, the TruAug. So they used what was called the TruAug method of phosphorus analysis. So back in 69, I guess, I don't know if Dr. Malik had developed either one of his extractants in 69. I can't remember the year of the Malik extractant papers. I think it was in the 70s or 80s, but I can't remember off the top of my head. Anyway, they used what's called the TruAug method. Now, for any of you soil extractant nerds or grad students or even professors who are interested in this stuff, the TruAug method was developed in the 1930s. Okay, back then, they were still fidgeting with everything, trying to figure out how to pull a sample out of the soil solution and see what it means, see how it relates to plant growth. And the TruAug method is a very weak sulfuric acid with ammonium sulfate buffered to 3.0. That's nothing we use today. Okay, the Malik 1 is 2 weak acids, which are actually stronger than this acid. The acid concentration in this was like 0.002 normal sulfuric. Very, very weak compared to today with ammonium sulfate buffered to 3.0, so it was an acidic solution. But today it's not relative to really anything we have today. So I can't say that, say, 22 pounds per acre is X pounds of Malik 3 phosphorus. I don't know what that means. But all we can say is that back then they considered these levels, it says right here, these levels were considered to be low, 22 pounds per acre. But if you did that with a Malik 3, it might be 10 pounds per acre, it might be 60 pounds per acre, it might be 100 pounds. I don't know what it would be. Okay, but from them, back then, they said this was low. So they're identifying their location as a low phosphorus soil, which if you've been following along on the past several videos, when soil test phosphorus is low is generally when we see responses to the applied phosphorus, and when they're medium or high, we generally don't see a response to applied phosphorus. The soil pH was 5.5 and 4.7 in the fall and spring seeding test areas, respectively. The soil pH was raised to 6.5 by applying agricultural limestone. So they raised the pH a little bit from 5.5 and 4.7 to using lime. So they raised it up. Okay. Now the treatments, they were replicated. So they had three replications, and one of the treatments was fertilizer placement. So they had 3 different placement regimes or methods. They either raked it into the top 1 centimeter. So they just put it on the surface and raked it in a little bit. That was method 1. Method 2 was they incorporated it into the upper 10 centimeters, or they mixed it or tilled it in to the upper 10 centimeters, which is 4 or 5 inches. And the method number 3 was they did 3/4 of it blended in and 1/4 on the surface. So we have surface application, we have blended application, then we have a mix of the two. And then all the treatments, the fertilizer treatments, all were applied according to one of those 3, or all 3, all 3 methods of incorporation. The phosphorus rates were 490. So I'm going to convert this to English units so we don't get confused. 490 grams per 100 meters, which is 1 pound of phosphorus. They applied 1 pound of phosphorus, 2 pounds of phosphorus, 4 pounds of phosphorus, or 8 pounds of phosphorus. Okay. So those were the phosphorus rates, 1, 2, 4, and 8 pounds per 1,000 square feet. And then the nitrogen rates were 1.5 and 3 pounds of nitrogen as ammonium nitrate. So it's a nice little study. They did 1.5 and 3 pounds of N. They did 1, 2, 4, and 8 pounds of phosphorus. And they put the products in the soil in 3 different methods, either tilled it in, surface applied, or a mix. They seeded Marion Kentucky bluegrass, 25% Marion Kentucky blue, 25% common Kentucky blue, and 50% red fescue. So that's the grass that they used. Visual estimates of turfgrass quality, which gave equal weights to uniformity, texture, density, and color, were a major means of evaluating turfgrass response. The rating scale varied from 0 for bare ground, or 10 up to 10 for ideal turf. Turfgrass quality ratings were taken monthly. So back then they were doing 0 to 10 as opposed to 1 to 9. That's fine. It's just a different scale, but they're using a standard scale, and they're telling you what the scale means. On 6 occasions, clipping weights were obtained as a means of measuring growth response to treatment. So they have a visual assessment using your eye, the human eye, and assigning a subjective rating to it. And they have an objective measurement with clipping yields to determine what impact it has, the nitrogen and phosphorus have on the establishment of this bluegrass fescue blend. They're in Rhode Island. Okay. So let's get to the results. This is a pretty short paper. Fertilizer placement results. The initial response to fertilizer placements in the fall test, as recorded in 63 and 64, showed that the surface and the blended surface and mixed placement gave a significantly better response than when the fertilizer was incorporated throughout the upper 10 centimeters of the soil. Okay. So if you get what I said the day or two ago, is like I'm not a real big fan of blending stuff into the soil where we know at that moment there's 0 chance the turfgrass can take it up because there's no roots in the soil at that moment. The seed either hasn't germinated or the sprigs haven't grown down into the mixture or whatever the case is. I'm not a real big fan of that. It just, something about it just doesn't connect with me because, yeah, the phosphorus isn't going to move that much, but you know, when we know we have 0 chance, it's like buying stock. Why would you, the stock might go up, but if you're told from the very beginning, when you buy this stock for the first week or 2 weeks or whatever, I'm going to guarantee you that that stock will not go up no matter what. Well, then why would you buy it? Now, granted, maybe it goes up in the future, right? But at that moment, there's no chance it's going to go up. Then I wouldn't buy that stock. It's a little bit the same here. At that moment, there's 0 chance. You can always apply it to the surface. And in this case, the surface and the mix of the surface and the blend showed a significantly better response than blending it in only, whether nutrients are out of range of the roots at the time of seeding or at the time of germination, I guess. Thereafter, though, okay, fertilizer placement responses were not evident. Okay, so the initial fertilizer placement treatments did not, they showed a difference at the beginning, but after that they didn't, meaning once the roots got into the soil and once the roots penetrated and started growing, then they didn't really see much of a difference between the 2 incorporation methods. But in the meantime, between initial seeding and the time when the methods did not differ, you've applied product and nutrients that have a potential risk of off-site movement. Okay, and 0 chance of plant uptake. Okay, I don't know if we can see these. I don't know if we even need to zoom in on the tables or not, but yeah, let me see if I can zoom in on this table. Good luck with that, huh, guys? You guys know my limitations on this stuff. Well, I'll see if I can. These tables are quite small. So this is what they're talking about. In December 63, we're talking about the surface application compared to the mixed application comparing to the blend. You see a 0.5 point reduction in the quality rating from 7 to 6.5. Okay. Now the phosphorus rates, well, we're going to get to that. I guess I should wait and get to that and show that next. They're just talking about the placement right now. Okay. Sorry if I can't seem to move my PDF over the way I want to show it up on the screen when I zoom in. Okay, so the next thing is the phosphorus rates. Oh, here they talk about the TruOg soil test. Okay. Yeah, so it's not really relevant. So don't take that 22 pounds per acre phosphorus number as anything remotely important or relative to what we're talking about in your soil today. Turfgrass, so the phosphorus rate. Now we're going to talk about the phosphorus rate. Turfgrass response to phosphorus levels was not consistent. Table 1. That's what we just showed up here. First, I'll go back to that in a minute if we need to. For the fall test in December 1963, the 1 pound of phosphorus rate resulted in a significantly lower turfgrass quality rating than for the higher rates. So that's right up here. We see I don't know if it's hard to read that. I know this table is tiny, tiny, tiny in this thing. But we're talking about a rating of 6.1 relative at the 1 pound phosphorus rate relative to a rating of 7 at the 2 pound, and then all the higher phosphorus rates were also 7.1. Okay, so when they applied 1 pound of phosphorus, they saw an acceptable turf, but it was 6.1. When they applied 2 pounds, they saw an increase. Okay, in the first rating date. All right, but they didn't see that. You'll see in the next couple, and they didn't see those increases in the next rating dates, as I guess they're going to talk about right now. Oh, here we go. Thereafter, no difference was detected until September 1965. So the next year, when the high treatment, which was 8 pounds of phosphorus, treatment had significantly higher quality rating than did the other phosphorus rates. So they're talking about 1965, and you're talking about this one right here, where the phosphorus at the very high rate resulted in a turf quality of 5.5, whereas all the other phosphorus rates resulted in a quality of 4.8 to 4.6. So they're all low in the quality rating scale, but the high phosphorus resulted in a little bit higher quality than the lower phosphorus rates. For the spring test, the turfgrass quality ratings in 1962, this is 1 month after seeding, increased progressively and significantly with increasing phosphorus levels. By mid-October, the plots which had received the least phosphorus had significantly higher turfgrass quality. Thereafter, phosphorus rates did not affect turfgrass quality. So now they're talking about this study, the spring test. This was in the fall test. Now they're talking about the spring test. They're talking about these right here, okay? The high rate of phosphorus was greater than the low rate of phosphorus and so forth. And you can see it down to about, well, whatever they said. So whatever the dates were. And then after that, you'll see these starting basically in November of 64. Around that November, there's no differences in the quality based upon the high rate or the low rate of phosphorus. Now here at the beginning, and this was in July and August of 1964 at the spring test, even the low phosphorus rate still had a quality rating of 7.5. It's just the high phosphorus rate had a rating of 8.2, so half a point higher. Okay, so there is some evidence here that higher phosphorus rates in this case resulted in higher quality, but the low phosphorus rates are probably adequate. As shown in Table 2, in November 1963, the fall test clipping yield increased progressively and significantly with increasing phosphorus levels. I'll get to Table 2 in a second. However, by the following June, clipping yield in relation to phosphorus levels had reversed. In the spring test, the clipping yield was not affected by phosphorus level. Phosphorus level did not affect species composition of the turf. Okay, so in Table 2, this is now dry clipping weights as influenced by placement and rate of phosphorus and nitrogen. And what they're talking about is we're looking down, so from 1 pound all the way to 8 pound of phosphorus, and you'll see in November of 1963, and this was the fall test, you'll see that the high rate of phosphorus resulted in 24, grams per kilogram? What is this? Yeah, grams per square meter. Okay, kilograms per, okay. So grams per square meter, 24 versus, nearly a third of that from the 1 pound phosphorus rate. Okay. That continued a little, that reversed. So at the beginning in November, you saw a beneficial response to applying more phosphorus. Now that same test measured 6 months later, the high phosphorus is actually resulting in lower yields. And then by the next year, there was no differences between the phosphorus rates. So we're seeing conflicting data from the same study where sometimes the high phosphorus results in a beneficial response. Later, we see it switch and it shows a detrimental response. And then even further down after the initiation of the study, we see no benefit or detrimental effect of the phosphorus at all. Okay. Sometimes that happens. You get these U-shaped responses where you see a response or an upside down U where you see a response of sometimes, and then you see it go down at higher rates and then it switches around sometimes. These are unusual, but they do happen in some of our studies. That's why we do studies. We try to explain it and publish it, and then somebody else comes along and says, you were right or you're wrong, and they build on it from there, right? But you still got to publish it. Okay, since differences in available phosphorus in the soil were found, So that was available soil phosphorus in table 3. Since differences were found, the clipping collection in September 1965 from all the spring test plots which had received the 4-pound rate of phosphorus and the 8-pound rate of phosphorus at establishment were analyzed. The average percent phosphorus found was 0.5, and no treatment differences were observed. So in other words, what they're saying is because there were differences in phosphorus in the soil at this time, we went ahead and took clipping analysis and we analyzed the phosphorus in there. And the average phosphorus was 0.5%, but there were no differences in the treatments. So even though it had high phosphorus in the soil or it had low phosphorus in the soil, it didn't correspond with what we found in the tissue. And that is very consistent with the literature. For years, in fact, when I was doing my master's and my PhD, there was a student who was attempting to correlate soil test values with tissue test values. And I don't really ever know what happened to that, to be honest with you. I don't think it was ever finished. But that's consistent literature. Just because you find high potassium in the soil, let's say you have 2 locations, 2 houses, one is or 2 football fields or 2 fairways, and one is high in potassium and one is low in potassium. And you take the tissue samples from them. Well, both tissue samples might be identical. They don't, or they might not be identical. But it's very common to see similar tissue analyses from turfgrass grown on soils with high phosphorus versus low with that element, with high phosphorus or low phosphorus. If it has high potassium or low potassium, generally the tissue analysis will be roughly the same. It's not normal to see differences. Just because the soil test values are different. It might seem counterintuitive, but that's generally what we find in the literature. Certainly there's exceptions to that, but that's generally what we find. Now that was the phosphorus rate. So basically there were times when the phosphorus benefited, there was times when it didn't, and there's times when it had negative effects, and there was times when it didn't. Okay, on both quality and dry clipping weight. When the soil phosphorus went up in response to the application of phosphorus, of course it did, but it didn't result in a consistent result. It didn't result in a consistent increase in turf quality, nor clipping yield, nor tissue analysis increase. So that's just like we talked about I think the last 2 episodes, we've talked about you're applying phosphorus, you're applying a product that has phosphorus. You're not seeing a lot of benefit from it. In many cases, you're not seeing any benefit from it, but you're consistently increasing or inflating the phosphorus in the soil. And that's the same thing he found. These authors found in 1969. Okay? It is, 1969. So that's been pretty consistent from 1969 to the present day, is that you're applying products that generally don't give a consistent response, like phosphorus. You don't generally see a consistent response to it. But you always see the soil test go up, soil test values go up, which increases the potential for environmental risk. We want to be aware of that. Now, let's go to nitrogen rate. As shown in table 1, the application of, what was that, 2 or 3, 4 pounds. Is that what is application of 4? No, 1.5 pounds. They did 1.5 pounds. Sorry, I'm trying to do this math in my head. 1.5 pounds of nitrogen resulted in better initial turf quality than the 3 pounds of nitrogen. Wait, that doesn't look right. No, this is the 3 pounds. Okay, I'm sorry. The application of 3 pounds of nitrogen resulted in better initial turf quality than the 1.5 pounds nitrogen. In the fall, which makes sense, you're applying more nitrogen. In the fall, the benefit from the higher nitrogen rate disappeared by early summer 64. In the spring test response from the higher nitrogen rate, in the spring test, response from the higher nitrogen rate was apparent during most of the observation period. The clipping weight data for the fall test showed no response in clipping yield from the higher nitrogen rate. However, in the spring test, a significantly higher clipping yield was found in the higher nitrogen plots on 3. The response to the higher nitrogen establishment was more persistent through the. So I'm not going to talk about nitrogen too much. When you apply more nitrogen, generally you see the quality go up. Generally, you see the yield go up. It's very consistent in literature. What they're basically saying is we saw that early on. We didn't see it so much as the nitrogen was depleted or from the source we applied. That's pretty straightforward. Okay, let's get down to visual estimates. Percent bluegrass in the turf. Okay, no significant differences resulting from establishment treatment were found for the fall test in 1965, possibly because this was 2 years after establishment. Okay. So after it's been established, these treatments did not have an impact really. For the spring test, that was in the fall test. The spring test, percent bluegrass estimates made in the fall following establishment showed significantly more bluegrass in the high nitrogen plots, 64 versus 78. That's biological. On September 1965, for the spring test, no significant differences from nitrogen treatments remained. Okay. Neither the fertilizer placements nor the phosphorus rates affected the percent bluegrass composition of the turf. Let's go down to the roots. No significant difference in root weights resulted from treatment variables were detected at either the 0 to 5 or the 5 to 15 centimeter depth. So what they're saying here is real simple. They applied nitrogen, they applied phosphorus at different rates and different placements, and they didn't see any influence on the root weights. And I always get a kick out of these things on YouTube and Twitter and wherever else it is, where the people are holding up turfgrass plugs and saying, "Oh, look at my roots, and I got great roots," or whatever. I don't know if they realize how difficult it is, one, to actually measure roots. It's not fun. It's something you give a grad student to do or a staff member to do, because it is not fun to measure roots. And in addition to that, after you've done all this work measuring roots, measuring the length or the density or whatever, after you've done all this work, you almost never see responses or treatment differences in the roots. Sometimes, obviously sometimes you do, but it's not very normal. You have to have some pretty significant treatment differences in order to see differences in root growth. Okay. So don't be misled because someone applied whatever, Green Power Ultra or whatever. I'm trying to come up with some fake name. And they show these are the roots, Well, of course they're not showing, what happened when you didn't apply it. So, and the roots are important, but it's rare that you see a response. So much so that you can actually consistently measure root differences between treatments. Okay. Coming down to the end, the discussion is just as short as the introduction. No significant differences in root weight. Okay, so no significant difference in root weights. It's that simple. So if you want to increase root rates, this study in 1969 didn't measure anything from various nitrogen and phosphorus rates applied at 3 different methods of application. So the discussion is super short and the conclusion is super short. So I'm just going to read the whole thing. Turfgrass response to establishment treatments were of short duration. Okay, right here. Turfgrass response to establishment treatments were of short duration. On many of the scoring dates, especially for the fall test, no differences among plots were detected, so general overall scores were given. Turfgrass quality declined rapidly where only an establishment fertilization was applied. However, portions of the plots which received spring and fall applications of maintenance fertilizer produced turf which averaged 2 or 3 points higher in quality. So makes sense. They applied just the establishment product versus the maintenance product. When you're doing just the establishment, you're only going to see response for a short period of time. So longer isn't better is the question in Lush and in the chat. Is longer isn't better. I'm sorry, I don't understand that. So longer isn't better when it comes to. I'm sorry, my mind's already on to the next topic, Lush. I apologize. What was I saying? When it comes to longer is better, give me a little bit more and I'll reply. I'm going to continue. However, portions of the plots which received spring and fall applications, no zero level checks for nitrogen and phosphorus were included in the experiment. So this is also, and he mentions it, they mention it right here. So they didn't include a non-treated control. And I'm trying to do, if it ever rains, I'm trying to do a study now where we're looking at soil test philosophies. And in that, I'm including a non-treated control because it's not biologically reasonable to never apply nitrogen, never apply anything, never apply water. That's not practical. It's not what we do. So oftentimes it's omitted. But in some cases, we need to know what would have happened if you didn't do anything, because oftentimes comparisons or incorrect comparisons can be made if you don't include a non-treated control. For example, if you let's say we're doing soil test 1 versus soil test 2, and we want to know how much this soil test recommendation influenced turfgrass growth. Well, you're only going to be able to compare between those two soil tests if you don't have a non-treated control. So you could say, well, this soil test recommended 1 pound, and this soil test recommended a half pound, and the half pound was better. Okay, because it resulted in adequate turf and you applied less nitrogen or whatever. But we don't know what happened to nothing. In other words, maybe the non-treated control also looked perfectly fine, and you didn't need to apply any nitrogen at that time of year. So in that case, we need to include a non-treated control in order to have a frame of reference as to the magnitude of the impact of any of the treatments. Okay, but understand, I get it when we don't include it because it's not biologically or horticulturally relevant to not do anything. Turf's going to die probably. Okay. Turfgrass response to fertilizer, especially nitrogen, has been well documented. Turfgrass quality in the unfertilized border. Okay, that's irrelevant. Okay, so they did say they didn't include an untreated control, but they said in the borders, they said that borders were 2 to 3 points lower. That wouldn't be allowed today, to just say what happened where we didn't apply anything if it wasn't a treatment. But they did it in this. They're just simply trying to say that if we didn't do anything in the borders and it looked bad. Okay, let's get to the conclusions. Based on the results of the fall and spring establishment studies, the following conclusions can be made. The 3-pound nitrogen rate applied at establishment resulted in better turfgrass quality and increased top growth during the early period of turf development than the 1.5 pounds. Straightforward. Love straightforward conclusions, okay? Or did I say results earlier? I meant conclusions. Let's get to conclusions. Effects of the higher nitrogen rate lasted longer for spring establishment than for the fall establishment. Okay, so if you're going to go out in the spring, you expect to see longer results. The nitrogen lasts a little longer, or the response to the nitrogen lasts a little longer than if you did it in the fall. The surface and the 3/4 mixed throughout, so the surface application and the mix of blending and surface application placement proved to be equally satisfactory. So you can just, in this case, you can just apply it to the surface. You don't need to blend it in because both of them resulted in the same response. Both of them were better than mixing it into the soil. And by applying it to the surface, you're eliminating or you're greatly reducing the risk of offsite movement of any nutrients that were placed below the rooting zone. And you're not gaining anything from mixing it in this setting, in this study. Mixing phosphorus and nitrogen throughout the surface, or throughout the surface 10 centimeters, throughout the top, 4 or 5 inches, gave inferior results in the fall. Okay. So they're saying mixing it in, blending it in gave inferior results. It's straightforward. All right. More evidence, more confidence you can have of avoiding that. And I know there's studies that show that, but this one shows it didn't have a benefit compared to just applying it to the surface. The turfgrass response to phosphorus levels was inconsistent, as we mentioned. So if you're looking at going out and applying a bunch of phosphorus to a blend of bluegrass and, bluegrass and tall fescue or bluegrass and whatever it was, this is at best inconsistent on soils that are considered low in phosphorus. In this soil test extract, and they considered it low. Okay, at best it's inconsistent. You might see a result, you might not see a result. Most of the literature we've gone up to this point has shown that you're probably not ever going to see a result if the Mehlich 3 phosphorus is, say, 38, 39 or higher. Okay. When you get lower than that, we don't know exactly where the line is yet for establishment of turf. What is that line? What is the magic Mehlich 3 number? I don't know. I suspect it's somewhere probably between 10 and 20 based upon other literature that's been published. But I don't know. But certainly there's pretty good, strong evidence that anywhere near 40 Mehlich 3 phosphorus or greater, you have very little chance of seeing a response to phosphorus. And in this case, they're saying it's low, and even when it was low, it was inconsistent. So take it for what it's worth. No differences in root rates resulting from any of the treatments. So forget about root rates according to these authors. Root rates did not change. They were the same. In general, the effects of establishment fertilization treatments lasted for only a few months. So if you're like myself, I did apply some nitrogen out here to some establishing tall fescue. It just doesn't look right. The front lawn looks okay, but the back lawn just something doesn't look right. It's a little slow. It's not growing well. So I added some nitrogen 2 days ago, but very little. But I'm willing to put up with that. Where I'm going with this is I'm willing to, I don't need rapid establishment. I'm not looking to get it grown in 3 weeks. Okay. If I want to do that, I'd get perennial rye or something. I'd just, load up a huge array of perennial rye and it'd grown in 3 weeks. It'd look great. But I don't really care how fast it grows in. What I care about is the long-term, and I'm going to use a word I don't like, long-term sustainability. I'm not sure how to define that sustainability word in the world of turfgrass management, but I'm just looking for, I don't really want to do anything to my lawn. I don't like mowing my lawn. I don't like fertilizing and watering my lawn. I don't like, as I tell this analogy all the time, it's like mechanics who work on cars for a living. They don't necessarily want to come home and work on their own car all weekend after they've been working on, 40 cars all week. I'm the same way with turf. I just want to come home, enjoy the lawn, have my kids running around in it, have the neighbor kids swinging from the tree swing in it, just having fun. I don't want to work on it. So my standards are average or low. I don't need the super high quality grass and fast and super dark green, and I don't need that. But if you do, that's fine. Just understand that in this case, when he says the effects of establishment fertilizer treatment lasted only for a few months, then that to me that's like, well, I'll just put out the minimum, or maybe not anything until I see it's not really doing well, and then just put out a little bit when I see it's not doing well. And then live with it, because in a couple months it's going to be the same anyway. Okay, but you might have a different opinion. You might say, hey, I can't withstand I can't tolerate any reduction in growth and all these things. I have to have maximum growth, maximum quality, and that's fine. If that's the case, then you'll need a maintenance fertilizer. But for me, I'm just a normal homeowner. I just want a normal lawn and to maintain it. So just understand that, it kind of depends on your interests, your human priorities. Like I said before, I get this from a colleague of mine. We don't have a turf problem. We have a people problem. Okay. The grass doesn't know any better. It's what the human expectations are that result in some sort of, issue down the road. If their human behavior or their activity isn't following best management practices, that results in it. The turf grass is not the problem. It's usually a human related issue that is causing issues here and there. But anyway, okay, that's all I got for this paper. It's very short and sweet. It's the first paper on phosphorus. Basically what it says, and summing this whole thing up, is apply it to the surface is the same, or I'm sorry, the applying to the surface was actually better than mixing it in. So why not apply it to the surface and avoid any offsite movement? The phosphorus did help occasionally. If when it did help, it helped early on, but it didn't help later on. The nitrogen, the high rate of nitrogen was, of course, greater than the low rate of nitrogen, but generally it was only early on. But it was inconsistent. Sometimes the phosphorus resulted in a good response, sometimes it didn't. And then the high rate of phosphorus resulted in a deleterious effect later on. It reduced quality later after establishment. So, or it resulted in that. So that's the take-home message. There's a benefit to applying phosphorus. There's a disadvantage to applying phosphorus. Apply it to the surface. Don't blend it in. It's kind of the conclusion of the paper. I'm not saying that. The paper's saying that. Okay. All right, guys. Remember, tomorrow is at 8 a.m. Eastern Standard Time. Dr. Ross Braun is scheduled to be on, as any professor is. Their schedules are very tight. And, as far as I know, he's still coming on. I'm pretty sure he is, but things change. He's got kids. I got kids, but he's coming on tomorrow morning at 8 a.m. It's an early show tomorrow. I'm looking forward to that. We've already talked about several of his papers. He does really good work, practical work. I like when it comes to scientists, I like a couple things. I like scientists who publish a lot, and scientists who publish a lot on practical work. And he checks all three of those boxes. So I'm really looking forward to having a conversation with him tomorrow about his paper. He can help, make sure I don't screw things up like I've done on some other papers. And then on Thursday, I'll try to do a Thursday afternoon show because I have to go to the dentist. If I can't, then I'll do it on Friday morning. Okay. Until then, guys, thanks for showing up. Thanks for participating in the chat. And we'll see you tomorrow morning, bright and early at 8 o'clock.